5.2 asks us to calculate the height of the tree after 10 years. So in the first year, we know that we have a growth of 150. In the second year, we've got 18, and then we're adding 8/9 of the previous year's growth. So if we want to calculate the height of the tree after 10 years, we have to then calculate what happens here for these 9 years. So we're going to have to sum these terms here. And we know that we had 150, and then 18, and then 16. The next one was 14 and 2/9. And we know that each time we were multiplying by 8/9 to get the next term. This is because we're multiplying a geometric pattern. So we know that we have A is 18, we know that R is 8/9, and we know that we are dealing with 9 years because the first year is already set. So on your formula sheet, you look up what the sum of 9 terms is for a geometric sequence. And we choose this form of the formula because our ratio that we're dealing with is a fraction. So we say 1 minus r. We would get the correct answer if we had r minus 1, but we're not going to choose that. It's easier to work this way. And now we substitute. And now you have to work on your calculator quite well. And I presume that you can do that. So we're going to say 8/9 into our calculator, y to the x to the 9, and you're going to subtract that from 1, and that gives you 0.65. At the bottom, you're going to get 1/9. It's really not necessary to break this down. I'm just breaking it down for you to assist you. You should be able to plug all of this in your calculator and land up with an answer of 105.88. But that doesn't give us the total height of the tree. It gives us the tree's height, which is growing between 18 and for the next 9 years. So the total height is going to be 150 plus 105.88, and that'll give us a tree height of 255.88, and we're working here in centimeters.